Hi, my name is Sarah Ballesteros, and this is my Physics 2211 Lab 4 on oscillations.
So the goals and findings for this lab, the goals were to examine the energy changes involved in an oscillating mass on a spring, and then using a given video, we would record and plot the energy changes that the model computes, and compare the predicted motion and the observed motion in both the x and y directions. For our findings, we were able to find the energy changes for the ball in the spring system, and we were also able to calculate the oscillation period for both the x and y position data. So here are our key ideas and formulas for this lab. So we were using Newton's second law and the momentum principle again. The momentum principle within the iterations in the code to update the velocity and position formulas, which you can see to the right. And then for our forces, we had the gravitational force and the spring force. And we can see those equations to the right. And then we were using the energy principle and the different forms of energy of kinetic, gravitational potential, spring potential, and our total energy. All of the equations for these are listed to the right. So for our diagrams of the spring, I have two diagrams here. The one on the left is for a spring that is compressed, and the one on the right is for a stretched spring. And we can see that there's always going to be a force that points downward due to gravity, and that the spring force is going to be parallel to the spring. So for the compressed spring, it's going to point down, and then for the stretched spring, it's going to point up. So for the initial conditions, I found the initial position to be -0.113, -0.632, and 0 meters, and then the velocity to just be 0 meters per second.
The mass to be 0.402 grams, the relaxed length of the spring to be 0.123 meters, and the change in time to be 0.095 seconds.
So for my glow script code, I put in the initial conditions, which is at the top. So we have the ball mass and then the initial position and velocity. And then down here, I used the equations for the kinetic energy, the gravitational potential energy, and the spring potential energy, and the total energy. So continuing with the code, this is in the iteration. So up here we have the force due to gravity and the spring force, and then we summed these to find the net force. Then I applied the momentum principle, and I used the position and velocity update formulas to update the values for these, and then I also used that to update the spring position values based on where the mass's position was. And then here I was using kinetic energy and gravitational potential energy and spring potential energy to find the total energy, again using the equations from the beginning. So here are results for total energy. We can see we have the gravitational potential energy in red, the spring potential energy in green, the kinetic energy in blue, and then the total energy in orange, and we can see that our total energy is equal to 0 here. So for our observed versus predicted graphs of position versus time, they're split into the x position and y position, and so we can see that both of them follow the predicted pretty closely. The x position does shift a little as time goes on, which is most likely due to the fact that we used the y position period for the initial value, which we can calculate the x position period later on, which probably would have solved this. And then for the y position, we can see that they're just all slightly off in the height, which is most likely due to the lower quality of the video. So what does this mean? Is the energy principle satisfied? Yes, it is. So no work was done on the system, so the total energy should have been 0. And then we saw in our total energy graph that it did end up being 0 because the gravitational potential energy and the spring potential energy counteracts each other. And then what I was saying beforehand back on the last slide about updating the periods based on the x and y position. So I found the x position period to be 1.6383 seconds and the y position to be 1.5194 seconds. And so if we would have used this exposition period, then it probably would have made our last set of graphs more accurate. Thank you.